look at like an equation at a point and say, is it continuous at this one point? Finding the domain is like, where is it continuous, like on the whole graph? So our job is to kind of list where things are okay instead of where they're not. So it's a similar process, but just the way you write it up is a little different. So 3 scenarios that would restrict the domain, that would be like not allowed. You cannot have a 0 on the bottom. I'm not sure what's supposed to go there. So if x plus 1 equals 0, there would be a discontinuity at -1. That's when the bottom equals 0. You can't have the bottom equals 0. But then what this lesson is not writing where the discontinuity is, but writing where it is continuous. So this function will be continuous everywhere except for that one spot. So you would say it's continuous from -infinity to -1 and -1 to infinity. Remember that the parentheses means you don't include that number. So like there's a parentheses on both sides of the -1. So we can't include -1, but we go all the way up to it from both sides. You can never put a bracket around infinity. You can't say like this is infinity. Then I can just be like, okay, add 1. You can keep going, but you can be like, okay, jackass, add 2. I'm like, yeah, exactly. So you can't put a bracket here. You can't have the bottom equal 0. Second one is you cannot take the square root of a negative. So the stuff inside of the square root has to be positive. So we would say 7x plus 3 has to be greater than 0. And then if I solve that, so I'd subtract 3 and divide by 7. Remember with inequalities, when do you change this sign? Divide by negative. Multiply over divide by negative. So I'm going to divide by 7 here, which means I won't change the sign. This would say x is greater than -7/3. So x has to be greater than -7/3 for that to work. So I would say -7/3 up to infinity. This is actually a valid way to write it too. You could actually stop there for that one. Because this is saying x can be any number bigger than -7/3, and that's exactly what this is saying. Can we just pretend like I said 3/7 and I said, so it makes sense? Okay. My bad.
Oh, I didn't even know this.
So I have to like start over because I screwed that up, or are we okay?
Can it be 0?
Yeah. Yeah.
When I wrote it, I wrote 3/7.
So it should be this. My bad. So 2 things. I have divided upside down. And the inside can be 0. You can take the square root of 0. What's the square root of 0? So the -3/7 is okay. It will be greater than or equal to. My fault. Those 2 okay? And then you can't take the natural log of you can only take natural log of positives. So I had to stop for a second. Before I saw me stop. Like, can I take the natural log of 0? So just to show you what I was doing in my head there, if I was asked to take the natural log of 0, remember what base is down here in the natural log? The e. And then you put like the equals y over there. So I would be saying e to what power gives me 0? But e is a number. Like it's 2.71828, but pretend it's just 3. 4. Can you do 3 to a power and end up with 0? You can't. So you cannot take the natural log of 0 was my point there, which means it has to be positive. Like you can take the square root of a 0, you You can't take the natural log. So the stuff inside has to be positive, so 2x plus 1 has to be greater than 0, which means x is greater than negative 1/2. What? It's all hard to read up here. Well, yeah, can I help you?
No.
Okay. So this is a valid way to write it, and that's about it. Or you could say negative 1/2, comma, infinity. So every problem you get, you gotta look for those three things. I might ask to take natural log, is there a square root? Can I get 0? Is that okay for the first, three, the notes right there? Let's do some examples. I look at number 1. There's going to be no square root issues there, right? There's no natural log issues there. But there is an issue where I might get 0 on the bottom. So I set the bottom equal to 0 to figure out where that might happen. It looks like it probably would happen at x equals 0. So x cannot equal 0, right? You're not trying to find where it would. You're trying to find where it can and then list them around. X can't equal 0. So you would write from negative infinity to 0 and from 0 to infinity. Or in the book, I think they use the union symbol, which is that. It means or. It's the same thing. It's just like a list. You can do it either way. Yeah. If this wasn't here, yeah.
No, like all of them.
I wouldn't write it. Honestly, I don't have a great reason, but I've never seen that really. Number 2. So I got a couple things going on here. There is a square root. So what has to be true about x plus 5? It has to be greater than or equal to 0. So not just positive, because 0 works also greater than or equal to 0. And then if I solve that, I know x has to be greater than or equal to negative 5. But then there's a second issue in this one. What's the other issue? The bottom can't be 0, so x has to be greater than or equal to negative 5, but also x can't be 0. So we have to write that. So we really want to say from negative 5 to infinity, but we want to just stop at 0 and put the parentheses around it to break it up. So we're going to go negative infinity to negative 5 up to 0, and then 0 up to infinity. And this is a bracket because the negative 5 is okay because the or equals. I'm trying to write x is greater than or equal to negative 5, but I have to make sure I don't include 0, so I have to work around. Is that okay? Questions? Alright, 3. Again, there's a couple issues here. First of all, the stuff inside of the square root has to be greater than or equal to 0. Well, I think there's an x, so x has to be greater than or equal to 0. And then the bottom can't equal 0. So I'm going to find out where it does, and then work around that. So I'm going to set that bottom equal to 0. So if I add the square root of x to both sides, I get square root of x equals 2, and then if I square both sides, I get x equals 4. So that means I need x to be greater than or equal to 0, but it can't be 4. So I'm going to say from negative infinity to 4, 0. I really want to write negative infinity for some reason. 0 to 4. 4 to infinity. So it has to be greater than or equal to 0. So 0 and everything above it, but I have to work around 4 because 4 is not okay. How's that? Okay. Don't worry about 4. It's way more in the natural log issues than the actual calculus. Let's do 5. get started, remember we worked with like a number line, like 0, 3. So this is x squared minus 2x minus 1/7. This is 3 over x minus 7. And this is whatever the last one is. That just kind of helps you break it up and see where you're supposed to plug things in. You don't have to make the number line. I just think it's helpful, especially if you get stuck. You just go. They go back. Will you guys be back tomorrow for this class? The all in? No. Who's going again? Okay. Haven't watched their emails. Just so sorry. It was like a slow and
When are we supposed to go with that?
I mean you can. Alright, so if I look at number 5, I want to see if these two functions match. So I've got to check 0, 3, and then I've got some stuff on the bottom here that I got to worry about too. So first I'm going to plug 0 into these two and see if they match. Well, if I plug 0 there, I get negative 1/7. If I plug 0 in here, I get 3 over negative 7. So do these match? They do not, so is that a discontinuity? Yeah, what kinds? A jump. That happens at x equals 0. So x cannot equal 0. I'm going to have like a list of things over there, and we'll put them all together. If I check this one, so at 3, I'm going to plug 3 into both of those spots. So that would be negative 3/4. And that would be negative 6/8, right? Or, wait. Yeah, so they match, right? I'm asking you because I'm doing that. Yes, no. He says yes, we're going yes. Okay. So they do match, so is 3 a problem or is 3 okay? 3 is okay. Down here, what could x not be? 7. But is that really a discontinuity? Am I going to say x cannot equal 7? I'm not. Why not? Yeah. So this is telling me x equals 7, but this part doesn't get to control what happens at x equals 7. This part only controls 0 and 3. So you can't be here and be like, hey, you guys over there don't use 7. That doesn't work. So 7 would be a discontinuity if this went past 7, but it doesn't. So 7 doesn't count. Here, I can get a 0 on the bottom if x equals 5, and 5 easily in this area, so x cannot equal 5 either. So you would build around those things. So negative infinity to 0, 0 to 5, and 5 to infinity. Questions? Alright, let's say you guys start working on the assignment and see how it goes. If you get stuck, we'll do more together. If you're good, you're good.